Hello students, today we'll be studying about crystal lattice, the characteristics of a crystal lattice, what is a unit cell, what are the characteristics of a unit cell, and so on. Okay, so let's not waste time, let's start. So let us start with what is a crystal lattice. Let us answer that question. Well, talking about crystal lattice, it's basically it's a regular three-dimensional arrangement of what? Of some points in a space. Okay, it is a regular. That is how the definition is. I'll just write it down. It is a regular three-dimensional. Okay, 3D three-dimensional arrangement of points in space is called a crystal lattice. Okay, a regular three-dimensional arrangement of points in space is called a crystal lattice. Now let us see what are the characteristics of crystal lattice. Okay, and see, this is a crystal lattice. I'll show you an image. It's basically it's just like how we have defined it. It is a regular. See, it is a regular three-dimensional. Oh, it is a regular three-dimensional. See here, it is a cube, right? So many cubes, when kept close together, we'll get something, see, like this, a crystal lattice. So it is a regular three-dimensional arrangement of points in space, and that is a crystal lattice. Now let us see what are the characteristics. Okay, what are the characteristics of crystal lattice? Here, each point in a lattice is called as the lattice point or lattice site. Each point is called this point, right? It is called as lattice point or lattice site or lattice point. And each point here will represent each point in this. First, let us write the first point. Each point in a lattice is called lattice point or as lattice site. Each point in a crystal lattice represents one constituent particle, and that constituent particle can be atoms, molecules, or ions. So first point is that each point in a lattice is called lattice point or lattice site. Each point in a crystal lattice represents one constituent particle. See, if this point, each of this point, right, will represent one constituent particle, and this constituent particle can be an atom, it can be a molecule, or it can be an ion. Okay, now the third one is lattice points are joined by straight lines to bring out the geometry of the lattice. See, just take a look at this diagram shown here. Okay, so here you can see they are joined by lines, right? See here, this is a line, and see, they are joined. Only if they are joined we'll get a particular geometry, right? Only if we join the lines. See, when we join the lines we're getting a cube. So only if we join we'll get a specific geometry. So lattice points, so the third point is lattice points are joined by straight lines to bring out the geometry of the lattice. Lattice points are joined by straight lines to bring out the geometry of the lattice. So what is a crystal lattice? A crystal lattice is a three-dimensional arrangement of points in space. And the characteristics of crystal lattice, there are 3 points that we must know. Each point in a lattice is called as a lattice point or lattice site. Each point in a crystal lattice represents one constituent particle. Lattice points are joined by straight lines, and that brings out the geometry of the lattice. That is all about crystal lattice. Next we have a unit cell. Okay, see this diagram? See, this is what it is. This is the lattice point, the points here. What is a unit cell? A unit cell is the smallest. I'll write the definition of a unit cell. It is the smallest portion of a crystal lattice. The smallest portion of a crystal lattice which when repeated in different directions generate the entire lattice. Unit cell is the smallest portion of a crystal lattice, and when it is repeated in different directions, it will generate the entire lattice. So this is a cube, right? When I join these two lines, we'll get another cube. So it will generate an entire lattice when we repeat the same thing. See, when the same thing is repeated in different directions, it will generate an entire lattice. Okay, so yeah, like that. So what is a unit cell? Unit cell is the smallest portion of a crystal lattice. See, let me take the pen. See, this is a whole crystal lattice, and see, this is the unit cell, just a small portion of a crystal lattice, and when it is repeated in different directions, it will give us an entire lattice. So what was the definition of a crystal lattice? A crystal lattice is a regular three-dimensional arrangement of points in space. Now when we come to unit cell, it is the smallest portion of a crystal lattice, and which when repeated in different directions will generate the entire lattice. So that is a unit cell. A unit cell is the smallest portion of a crystal lattice which when repeated in different directions give us the entire lattice. Clear, right? Okay. Now let us see what are the characteristics of a unit cell. Characteristics of a unit cell. Okay, the first point to keep in mind when we talk about unit cell is that a unit cell has 3 edges and 3 angles. You needn't write it as a point, okay? It has 3 edges, 3 angles, and the 3 edges are A, B, C. 3 angles are alpha, beta, gamma. Alpha, beta, gamma. Okay, and this is the picture of a unit cell. Okay, this is a picture of a unit cell, and this picture has all these things marked in it. See, the 3 edges are there, 3 angles are there. So this is basically the characteristic of a unit cell. A unit cell has 3 edges A, B, C. See, this is edge A, this is its edge B, this is its edge C. It has 3 edges A, B, C, and it has 3 angles alpha, alpha, beta, gamma. Alpha, beta, gamma. Now another important thing which you must know is that where will these angles be? You have to write each of these, right? You have to draw and mark all the angles and all the sides, all the edges. Only then you will get the entire mark for answering what are the characteristics of a unit cell. So how you should do is like this. So characteristics of a unit cell, you should write a unit cell has 3 edges A, B, C and 3 angles alpha, beta, gamma. Then you must write angle between A and C. Angle between A and C equals beta. See, beta is the angle between A and C. Angle between B and C is alpha. This is B, this is C. Angle is alpha. Angle between A and B is gamma. See, this is A here, B is here, gamma. Don't by heart this. According to your figure, you can change the alpha, beta. That is not. That's all okay. So you shouldn't by heart this. If you by heart this, then there are chances of going wrong. So just draw a unit cell and take any 3 edges and name it as A, B, C and put the angles between them. Angle between A and C here in this figure is beta. Angle between B and C here is alpha. And between A and B here it is gamma. Okay. Next, that's all about a unit cell and the characteristics of a unit cell. Then they can ask you this question. Okay, I'll write the question. Name the parameters that characterize a unit cell. This is a very important question. Name the characteristics that name the parameters that characterize a unit cell. What are they? They are the 3 edges A, B, C, 3 edges A, B, C and 3 angles. 3 edges A, B, C and 3 angles alpha, beta, gamma. So these are the parameters that characterize a unit cell. It has 3 edges A, B, C and 3 angles alpha, beta, gamma. Okay, clear, right? So this is all about, this is what we have to learn about crystal lattice and the characteristics of a crystal lattice we studied, then unit cell and the characteristics of a unit cell and what are the parameters. That is enough for today. Now in the next session we will be looking more into unit cells and how they are being divided and what are the different types of unit cells and all those. So for today, let us stop till here and till then see you in the next session. Bye bye.